If you look in your syllabus, there is dates posted on each syllabus and what lecture will be posted on that particular date. So make sure you follow your syllabus. You know that the lecture is posted. There'll be discussion forums for each of these lectures, which means you can ask any questions related to that lecture on the discussion board. So today what we're going to talk about is a lot of terminologies. When we talk about speech science, first we need to understand some basic terminologies to be able to carry these terminologies through the rest of the course to understand the acoustics of speech sounds. Bear with me. All of this might sound jargon to you the very first time you hear it, but we'll get through this. I will stop. I will repeat a few things. And again, as I said, if something is not clear, you always have the ability to contact me via discussion boards for your questions. Okay? So you're in the field of speech now. So there are some things that we really need to understand. We all kind of intuitively know what language is, what speech is, or what thought is. Now, if I were to put a definition to each of these or make you start thinking about this, can you describe what language is, what speech is, or what thought is? Okay, so the first thing that we're going to understand is what are these three terminologies. What is language? Now, we all use a certain language, a system that is comprised of signs, a system that is comprised of symbols, gestures, or certain rules used in communication. So, for example, we have spoken language, we have written language, and we have sign language, right? They're all ways of using the system of signs or symbols. So, spoken language is, for example, English is your native language. So you use certain words, you combine those words in a certain order to be able to convey your meaning to the listener, right? Even sign language is a form of language because you use certain rules to convey the meaning using signs, a set of gestures to be able to convey it. Even your body language is a way of conveying information, okay? So when we talk about language, for example, in English, we combine the words, how are you, right? Meaning, how are you, right? I don't have to give you the meaning for that. But if I were to use that in my same language, as you all know by now that I am not a native speaker of English, I am from India originally. So my native language, I will say, ni eppadi irke, you how are, okay? But that is a syntax that I use in my language. Those are the rules that my language has to combine those words to make sense to the listener. So, in sum, a system that is rule governed where meaningful elements are combined to make sentences. Okay, so that is language. We all know intuitively what it means. But when we talk about language, there are 5 things that govern a language. When you enter the field of speech language pathology, those are some things that you will see, some disorders that are related to these 5 things that are governing the language. First thing you want to know is the 5 things are morphology, semantics, syntax, phonology, and pragmatics. Okay, what is morphology? Morphology is words, okay, and their smallest unit is called morphemes. Okay, morphology is words. Semantics is the meaning of those words. Okay, so if I use the word soda or I use the word pop, you know the meaning means you're talking about Coke or, some kind of beverage that is aerated, right? Soda, pop. That is semantics, the meaning of that word. Syntax is the structure of putting these words together. Okay, so as I said, what is your name? How are you? You don't ask what your name is, how you are, right? That is not the rule that is governing English. The rule that is a certain order or a structure the sentence needs to have. That is syntax. How are you? What is your name? Sometimes there are dialectal variations in the syntax that is used. For example, African American English has a certain dialectal variation where they use double negatives. Like, I know nothing. I didn't do nothing, right? I didn't do nothing. That is a double negative, and that's still okay because that forms part of their language that governs the rules of that language. And those are called dialectal variations. Okay. Phonology is what is going to be the focus of this course, is sounds, phonemes or sounds. Single sounds are called phonemes, and And that is what is going to be the focus of this semester, is phonology. And pragmatics is appropriateness or context specific. And I'm always bring this example, which is an easier example to understand, is if you're in a funeral home and everybody's crying, you don't want to be laughing, right? That is not a pragmatically appropriate situation. Or if your close friend comes and tells you how much trouble she is in, you don't want to laugh at it. Or if she comes and tells you how much fun she's having, you don't want to cry, right? Those are not pragmatically appropriate. Those are not very specific to the situation, context appropriate, okay? So a language has 5 things that govern the language. Morphology is words, semantics is meaning of those words, syntax is the structure, how the words are combined, phonology is individual sounds that make up these words, and pragmatics is the whole thing together, meaning the context appropriateness of the communicative situation, okay? So now we talked about language. Let's see what thought is. Now you're sitting at home, you're listening to my lecture, and you're thinking, okay, she said this is all going to be jargon. This is all going to be a lot of terminologies that I need to know. That is a thought, process of thinking or reasoning, or saying, oh, this is an online course. You're thinking in your head, I need to be looking at these lectures posted during the time when it is posted, because I have only 48 hours in my discussion board to ask these questions, which means I need to be taking, time to look at these lectures when it's posted. It's easy because it's online. It's easy to just not see anything for a week and then come back to it, but you've lost your time window to actually ask your questions for that lecture. Okay, that was a little deviation, but I wanted you to know that what you're thinking through your mind is actually a thought process. It's an internal representation of experiences. It can be images, it can be action, it can be language, anything that goes on without having to say it out. You're thinking in your mind. That is a thought process. So we have language, we have thought. Now we know this language is a system that is rule governed, but there is a way that we need to communicate this language, right? You can communicate this language through science. You can communicate the language through writing. You can communicate the language through speaking, that is able to vocalize, say it out. That is what is speech. Speech is vocal communication. It's one way of communicating language. It's one way of expressing or describing our thoughts by putting words or putting sounds together, okay? So it's conversion of language to sound. Our focus for this semester is going to be about speech, okay? We're going to talk about how these sounds are produced, which is in the phonetics part, and then we're going to talk about how do we recognize that certain sounds are produced, that is going to be the acoustics part, and how do listeners perceive, that's also going to be the speech perception. So we did language, thought, and speech. Speech is nothing but a way of communicating language. We're putting sounds together and expressing or describing our thoughts in language. So I guess this is a speech science course, speech and hearing sciences. So what does speech science entail? Speech science is the articulation of speech, right? Articulation meaning how you're using structures in your mouth, how you're moving your tongue, your lips to produce certain sounds. That is articulation. Physiology of speech production is, there are 3 systems, and we'll talk in a bit what are the prerequisites of speech. There are 3 systems, your respiratory system, your phonatory system, your articulatory system. How do these systems combine to make that physiology happen, to make that speech sound happen? The acoustical characteristics of speech, and we will briefly in a little bit talk about what acoustics mean, is how do I know when I am saying I'm saying when I'm saying I'm saying or ooh, how do I know that certain speech sounds are being produced? That is how we understand, is using the acoustical characteristics of speech. The final thing is when I say something, how are you able to perceive as a listener, what did I say? Okay? So speech science is nothing but how we articulate speech, the physiology of speech production, the acoustical characteristics of speech, and the process by which listeners perceive speech, okay? So I said, when we talk about speech production, there are certain prerequisites of speech production, okay? The main thing that we need for speech production is a source of energy. We are talking on some source of energy. The source of energy here comes from our lungs. Okay? Our lungs supply the air to be able to produce any speech sound. If there is no air, we won't be able to sustain our speech sounds. And you will understand why when we talk about the respiratory system and we talk about the phonatory system. Once the air is there, the air can just pass through, but we need something to vibrate that air, and that is called the vibrating source. In our speech, the vibrating source is located right here in your neck, called the phonatory system or the larynx, and you have two structures called the vocal folds that vibrate together, producing this vibrating source or a sound. Once that sound is produced, we need to carry this sound across for the listener to be heard, right? To hear you. That is the medium of transmission, and in most cases for speech, the medium of transmission is air. Okay? And I summarize most of this. We'll just talk about each. As I said, the source of energy, you need something to activate a vibrator. That is the air from the lungs, which is your primary source. Your vibrating body, as I said, is the larynx, the two structures, the vocal folds that vibrate together like this. Now, when I don't have anything above my larynx, so I cut this part of my neck and I take my head and keep it aside, I only have a source, I only have a vibrator. Do you know what kind of sound is going to be produced without this structure right here? Bzz, 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 bzz. So I have air, I have my lungs, my larynx vibrating, that's the sound I get. The way it gets converted into speech sounds is how I move my structures in my mouth. Do I move my lips? Do I move my tongue? Does my palate close? Those are things that convert into specific speech sounds, okay? The final thing we talked about is the medium of transmission, which is the air. Now, I have been mentioning that speech science, we're going to talk about acoustical characteristics of speech. What is acoustics? Acoustics is a study of sound. In our case, it's a study of speech sounds. So you've heard about acoustical engineers, people that are in bands or orchestra, they're acoustical engineers, or for movies, acoustical engineers. They're all working with sounds, right? We are working with acoustics of speech sounds. We want to know what the characteristics of speech sounds are. Intuitively, we all know what sound is, right? But if I have to define that sound, what is sound? That is sound. That is sound. But how do I define this? It's an audible disturbance. Audible meaning something that you can hear. It's an audible disturbance of particles or molecules in a medium produced by a vibrating source. So the vibrating source, when I do this, is the table, right? When I talk, my vibrating source is my larynx. My medium for any kind of speech sound is usually air, okay? The disturbance that is created by these particles results in something called a wave. And hold on to that thought, because I'm going to talk to you about a waveform, and how you trace that in just a few minutes, okay? So all you need to understand is a sound is something that is an audible disturbance, something that you can hear of particles or molecules in a medium that is produced by a vibrating source, your larynx, for speech sounds. The way the transmission happens is through air, okay? This disturbance is a kind of, it results in a wave. The wave can be a pressure wave or a sound wave. And we will define pressure shortly. Okay, so hold on to that thought for a second. Now, if I were to tell you that sound is an audible disturbance of particles, these molecules or particles have to have certain properties for the sound to be transmitted or for you to hear the sound. There are two important properties that these molecules possess. One is the property of elasticity. Two is the property of inertia. Okay. Again, I think we've heard these terms. If you have taken any physics class, you would probably heard the term elasticity and inertia. If you haven't, those are not hard terms, they're pretty simple terms. Let's define elasticity. Elasticity is the property of a body to return to its original shape or position. So for example, if you take this rubber band, if you have one at home, try it. I stretch to the point of maximum. Beyond that, I can't stretch it. And once I let go, of course, it fell back and it returns to its original position. You see that? That property of a body to return to its original shape or original position, the property of springiness, is elasticity. Inertia is the property of a body to be in motion will remain in motion, and a body at rest will remain at rest unless it's acted upon by an external force. So for example, the good example here is actually a swing. Everybody has sat in a swing sometime, right? So when you are moving in the swing, you create this arc of motion, right? You're moving in the swing. The swing will remain in motion until you actually try to stop it, or over a period of time, if you don't do anything, it just comes back because there is not enough force to move it, right? So the ability to remain in motion until you bring a stop to it, or the property to remain at rest until you apply an external force, is called inertia. If you've seen a pendulum, okay? Let me do this. If I can bring this mouse, right? Think of this as a pendulum. I'm going to move this. This is heavy, so it's not going to probably do something like a pendulum. Okay? So the ability to just keep sliding like this, see? And then until I stop it, that property is called inertia. The ability of this to move until I stop it is going to be the property of inertia. So a body in motion will remain in motion, and body at rest will remain at rest until acted upon by an external force. Why is this important? We're going to see that shortly, because these are the properties of molecules. When the molecules move, it has to have these two important properties in order for sound to be transmitted. Okay? So two properties, elasticity, inertia. Now, let's talk about this. We are going to talk about the molecules and how these molecules will vibrate. This is a model of vibration of air molecules around rest positions. Okay, I'm going to grab the pen here and let's start drawing. Okay, so I want you to observe that positions 1, 2, 3, and 4 here. If you have your slides along with you, follow with me. Yeah, 1, 2, 3, and 4. These are rest positions. Okay, these are molecules, particles at rest positions 1, 2, 3, 4. This is A, B, C, D, and E are the movement of particles at different time points. Okay. So what I want you to do is I want you to start following with me the movement of this particle 1 from its rest position. At time point B, right here, I am applying an external force to my particle 1. It actually moves from its place and goes to position 2, that movement of an external force. Once it goes to position 2, it bumps with the particle 2, and that force will move the particle 2 away from its rest position. But ignore that. I want you to just focus on this particle 1. Once it reaches to that position, it has reached to a point of maximum displacement. The property of elasticity comes into play, the springiness or the ability of the particle to move to rest position. So it's moving to its rest position 1. But look at point D. It does not stop at its rest position. It goes beyond its rest position. That's the property of inertia. So here we have the property of elasticity, that is the particle wanting to return to its rest position. But when it comes to its rest position, it does not stop there because of the property of inertia, the ability of a body to stay in motion unless it's acted upon by an external force. Then at time point E, it still came back, but it did not stop at its rest position because of the property of inertia. So if you look at this graph right here, or this model right here, we have particles at rest positions 1, 2, 3, and 4. Look at how equidistant these molecules are at rest positions. Okay. And then I want you to follow this particle 1 when it's bumped at time point B by an external force. That's the arrow that you have there. It moved from position 1 to position 2. It bumped the particle in position 2, but I'm not going to talk about that particle right now. I'm only going to trace this 1. So when it reached to a point of maximum displacement at number 2, it came back. It's trying to come back to its rest position at time point C. That's because of the property of elasticity, a body wanting to come back to its original position because of the springiness. But when at time point D, it does not stop at its rest position. It moves away from its rest position in the opposite direction. And that is because of the property of inertia, a body wanting to stay in motion until acted upon by an external force. At time point E, it crosses again and moves away from the rest position in the other direction, the property of inertia. Now, If I stop that particle, it's going to stop. That's an external force. If not, over a period of time, the magnitude of this particle movement is going to decrease because of a property called damping, meaning loss of heat. And then it'll stop in its original position. Just like how your swing is. If you keep moving and if you're not applying that external force of you moving forward, over a period of time, if you don't try to stop the swing yourself, the swing will stop on its own. That's the property of damping, loss of heat. Okay? So, two properties that we have talked about, elasticity and inertia, and we have talked about how the models vibrate or the molecules vibrate and how these properties will help it come back to its original position. Now, while we are here, I'm going to talk about different pressures here. What is pressure? Okay. Pressure is the force exerted over a unit area and it's directly proportional to the density of air. More dense the particles, or when you see more particles, they're going to be more pressure. Less dense the particles is going to be less pressure. Okay, and I will talk to you in a little bit when we talk about more dense and less dense particles. So pressure is nothing but the force exerted over a unit area and it's directly proportional to the density of air. Three different kinds of pressure is something that I want you to know. I want you to know what an atmospheric pressure is, what a positive pressure is, and what a negative pressure is. Okay. When we talk about atmospheric pressure, look at this particle right here. 1, 2, 3, and 4. 1, 2, 3, and 4 are equidistant, okay, and the density of air is approximately the same at any given spatial location, meaning they're equidistant, they're spread apart, so the density between these molecules is going to be approximately the same. That point where the density is approximately the same at any given spatial location is the atmospheric pressure. Okay, if you look at this is also a good example of atmospheric pressure. Look at how equidistant each of these particles at rest are, and when they're equidistant, the density between these particles are same at any given spatial location. That is going to be our example of atmospheric pressure. Now, if you look at point B, time point B at position 2, you see those two particles in the same position. Now you add one particle to the other compared to this, the density of that is going to increase. When the density increases, the pressure is going to increase. When the pressure increases, that becomes positive pressure. Okay? Now we're talking about positive and negative pressure relative to atmospheric pressure. So compared to the time point A at position 2, there's only one molecule. That's atmospheric pressure. Compared to that pressure, the pressure at time point B in position 2 is going to be higher because there are two particles at the same time. Now, the same position 2 at time point C, there is no particles right here in the position 2, meaning they're apart, there is less density of the particles, and there is negative pressure compared to relative pressure. Relative atmospheric pressure. Okay, so three pressure things that I want you to know. Atmospheric pressure, where the density of any given particle is the same across different spatial locations. At time point B, position 2, there are two molecules, so there is going to be increased pressure compared to time point A, position 2. At time point C, position 2, there are no particles, meaning they're going to be less dense. That means there's going to be negative pressure compared to atmospheric pressure. Okay. Now, how does this help? In this drawing, if you see these areas that are, I'm going to use a different color, that are brighter and at the same point in position 2 they're duller. Those increased points is going to be positive pressure, and these decreased points is going to be negative pressure. So you have periods of positive pressure and negative pressure compared to the atmospheric pressure that's right here. Okay, this positive pressure or areas of increased density, positive pressure meaning increased density of molecules. When there's going to be increased density, that is called condensation. Okay, this decreased density, where there is going to be less pressure, negative pressure, is called rarefaction. Okay, so more terminologies. You see how we're going to keep talking about more terminologies. This is again related to pressure. Yep. All right. Compression or condensation is the areas of high density and high pressure. Rarefaction is areas of low density and low pressure. So we can see right here, when there is positive pressure, there's increased density, it's called condensation. Negative pressure, decreased density, decreased pressure, it's called rarefaction. So far what have we talked about in terms of acoustics? We talked about what acoustics is the study of sounds. In our purposes, it's going to be study of speech sounds. Then we talked about what sound is. How do we define sound? Sound is an audible disturbance of particles or molecules that is transmitted through a medium, in our case is the air, which is produced by a vibrating source. Our vibrating source is going to be our larynx, right? Now we talked about how these molecules will move at different time points when compared to rest positions if there is a force exerted to move that particle, and that was this figure. Oops, right here. So we tracked this, right? And we talked about two properties, elasticity and inertia of the molecules. Elasticity is the springiness property of springiness, ability to return to its original shape. Inertia is the ability of the particle to move and stay in motion until it's acted upon by an external source, okay? Then we talked about three different kinds of pressure: atmospheric pressure, positive pressure, and negative pressure. Atmospheric pressure is the density of the molecules is going to be same across different spatial locations. Positive is increased pressure relative to atmospheric pressure. Negative pressure is decreased pressure relative to atmospheric pressure. And we talked about condensation and rarefaction. Areas of higher density, high pressure is called condensation or compression. Areas of low density or low pressure or negative pressure is areas of rarefaction.